Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Last class I have discussed thermochemical equations. Now I am going ahead. Today I am going to discuss HESS law of constant heat summation. This is very important, and numericals, if you want to solve the numericals, then this concept is required. His law of constant heat summation is required. We know that enthalpy is a state function. Therefore, the change in enthalpy is independent of the path between initial state and final state. Initial state means reactants and final state means products. In other words, enthalpy change for a reaction is the same. Just listen carefully. In other words, enthalpy change for a reaction is the same whether it occurs in one step or in a series of steps. This may be stated in the form of Hess law. What is the Hess law? Now, statement of Hess law I am telling you. If a reaction takes place in several steps, then its standard reaction enthalpy is the sum of the standard enthalpies of the intermediate reactions into which the overall reaction may be divided at the same temperature. Okay. Again I am repeating, if a reaction takes place in several steps, then its standard reaction enthalpy is the sum of sum of the standard enthalpies of the intermediate reactions into which the overall reaction may be divided at the same temperature. Means either you do in one step or in several steps. If we will make the sum, if we will make the add all steps, then it will be same for the initial and final. Starting from initial to final, delta H value will be the same. Either you do in one step or different steps. Let us understand the importance of this law. Okay. With some example I will tell you, then you can understand. As per just you consider the reaction, simple reaction, graphite carbon plus half O2, carbon plus half O2, O2 means gas and graphite means solid. Then C plus half O2, C plus O2, CO2, you know product will be CO2. But here half O2 is there, only one O. Then it will form carbon monoxide, CO. CO, that is the gas, small g you can write. Then how will you calculate delta H? Heat of formation, only one product is there, CO. Hence you can calculate heat of formation, or heat of reaction also you can tell. Because only one product is there, then heat of reaction, in that heat of reaction, what type of reaction? Then formation. Then what is the value of delta H? How will you calculate? Then there is a simple method by the way you can calculate by use of Hess law. Okay. Then C plus half O2. What will the product? Product will be carbon monoxide, CO. Deadly poisonous gas. Then how will calculate delta H? That I am telling you. Okay. Although carbon monoxide, CO, mono means only one, mono means one. Although CO is the major product, some carbon dioxide gas is always produced. Actually, in real practice, if carbon will burn in presence of oxygen, then if it is more, if oxygen is more, then it will form carbon dioxide. and if oxygen is less, then it will form carbon monoxide. Actually, what is the mechanism? In real fact, that first it will form carbon monoxide, and after that, because more oxygen is there, then this carbon monoxide will convert to carbon dioxide. CO will convert to CO2. Okay. First carbon monoxide, first step, and in second step, if oxygen is more, then this CO will convert to CO2. You might have seen from the vehicles, when fume will come, it will be dark, and as soon as it will come in contact with the air, then that darkness will go. That will come because that time carbon was more, carbon monoxide. Then that carbon monoxide will react with oxygen presence in air, and it will convert to CO2. Then CO2 is light black. More black means carbon monoxide. Okay. Then now here I am telling you, with this reaction with C plus half O2, CO is forming major product, but there is a possibility for little carbon dioxide also. Okay, although carbon monoxide is the major product, some carbon dioxide gas is always produced in the reaction. Therefore, we cannot measure enthalpy change for the above reaction directly, because carbon dioxide is also may be there. However, if we can find some other reactions involving related species, if we can find some other reactions involving related species, it is possible to calculate the enthalpy change for the above reaction, means C plus half O2, that is equal to CO. How that you understand? Let us consider the following reaction, means C plus O2. Now not half O2, full O2 means more oxygen. Then it will form carbon dioxide gas. A small g you can write. Always if gas, I told you, physical status you have to write in thermochemical equations. Otherwise it will be useless. Two things I told you: physical status means physical state plus enthalpy change. H value you have to write. Only then you can tell this is the thermochemical equation, and it will be useful. If any one is not written, then it is the problem. Okay, you can't, it will be not useful. Then now just I am telling you that another reaction, C plus O2, C means graphite solid, plus oxygen gas, it will give carbon dioxide gas, and delta H value is a standard, you can say delta H value means heat of reaction value is minus 393.5 kilojoule per mole. This reaction you have to consider. This is the common reaction always. You should keep in mind C plus O2 CO2, that always we should know. And delta H value, if you are giving importance for the thermodynamics, then delta H heat of reaction, this also you can tell heat of formation, because only one product is there, CO2. Okay, then here delta HR also you can tell, delta F means heat of formation, heat of reaction, both you can tell. Okay, and that is equal to minus 393.5 kilojoule per mole. Okay, then due to this actually heat, when anything burns inside our body or outside our body, means wood burning, any coal burning, anything, when it burns, then from the 1 mole 393.5 kilojoule heat comes out from the 1 mole. 1 mole means molecular mass. Okay. Then this is giving 393.5 kilojoule per mole. Then you can think how much energy it is giving when it will burn more coal or more wood or even the LPG gas kitchen. How much it is giving heat, you can imagine. Okay. And okay, that I just to think only this reaction, C plus O2 CO2 and delta H, that is equal to minus 393.5 kilojoule per mole. Then this reaction is very useful. Now two reaction I told you. First reaction I told you C plus half O2 CO. Delta H value you are not knowing. You want to calculate. But this value you are knowing, C plus O2 CO2 delta H minus 393.5 kilojoule per mole, that you are knowing. Now third equation, third relation you can check. Third equation or equation also you can tell, or reaction also you can tell, no problem. Third equation is very interesting. Okay. Now what I told in the beginning that CO will convert to CO2. I am talking about that reaction now, third reaction. CO will convert into CO2. Then CO plus half O2. CO gas is there plus half O2, that is also gas, it will give CO2 gas. And in this step, heat of reaction or heat of formation, anything you can tell, that value is minus 283 kilojoule per mole. Minus 283.0 kilojoule per mole. Then now you can see three reaction you are knowing. Then first reaction for monoxide formation, you want to calculate delta H. For that purpose, you require these two reaction, means C plus O2 CO2 and delta H value is known, minus 393, and here CO plus half O2 CO2, its value is 100 degree less, means 283 minus 283.0 kilojoule per mole, 100 degree difference is there. Then now with the help of these two equations, first one you want to calculate delta H. Now with the help of these two equations, you can calculate first one. How? Then just you have to, it is very conceptual and very easy also. Easy means if you will understand, then it will be very easy. Okay, you can understand, I am sure. Then now here again, how you will understand, that you understand. Because see, always you think what you want. Always when you are solving the numericals, trying to solve the numericals, then always think what you want, and in that direction you think. Then now your intention is to know the this delta H value for the formation of CO from C plus half O2. C plus half O2 CO, then how much heat will evolve, that is your intention, that you want to know delta H value. Then now for this, you with the use of last two reactions, you can get that value. Then just to think, just you have to rearrange. You have to not do anything, sir. You have to rearrange. Means you can do left side, you can bring it right side you can bring to the left side. And already I told you, delta H value sign will change. Quantity will be the same, only sign will change. Means minus will become plus, plus will become minus. Only these two things you have to do. You have to do means to get your these things. What do you want? That equation, you have to bring that equation by just rearranging. Means you can do any one equation, you can do left to right, other you leave it. Okay, what is required? According to the requirement you can make transfer. Means you can just make just change left to right, right to left, and sign also you can make a change. Okay, only these things you have to do. Numericals actually is asked in examination. Okay, then now you have to utilize your common sense, that you want what do you want, that equation should come, that equation should come. Okay, that is your intention. With the help of these two last two equation, that equation, first equation should come. Okay, then quickly you can get the delta H value. Then here how will you get two reaction, last two reaction, that is C plus O2 CO, that value is given delta H value, and CO plus half O2 CO2. Okay, this delta H value is also given. Then now you know you want first equation. You want first equation, means C plus half O2 you want. Then how will you bring with the help of last two? Then see, second equation, C plus O2. C plus O2, C is there. C is there. Then okay, C, you in this equation don't make any change because you want to bring C. Then C is there. Carbon is there. Carbon graphite is there in second equation. In third equation, you can this it will be there. First, second equation you will not make any change, but where you will make change, then just you listen carefully. We can combine the above two reaction, means second and third we can combine. Then what we will get? We can combine the above two reactions in such a way so as to obtain the desired reaction, means first reaction, first equation. To get 1 mole of CO, on the right, actually right side CO should come because in the first product CO is in the right side. You want to bring CO in the right. Okay. Then what you have to do? Just you listen. Then to get 1 mole of CO on the right, we reverse equation second. Okay. Means second means here last two reaction, means third one you can tell. First you want to know. Then after that second and third two reaction I told you. Then third reaction means CO plus half O2 CO2. That you reverse it. Then CO will go to the right direction. Right hand side it will go. Correct? Third reaction you just reverse it. Then CO it will go to the right, and value will also, delta H value will change. Minus 283 will become plus 283. That's enough. And then last two reaction just to add. After you can say making this change, last equation you make it change. Right to left, left to right, and delta H just you change it, minus to plus. And after that then what you will get? You will get like that way. CO2 after changing last reaction, then CO2 will come to the left side and CO plus half O2 will go to the right side. Okay, right side it will go. Then and delta H value will come plus 283. Then this you can tell as the again a new reaction after changing. That is the, you can say, total fourth one after changing. Then this fourth after changing, and second one. Okay, second one means C plus half O2 CO2. Second one, and just now after changing you got the reaction, means second and fourth. Just second and fourth, just you add it. That's your problem is solved. Second and fourth. First you have reversed. Third you reverse, then you got the fourth. then this fourth and second, just you add it, then you will get C plus half O2, that is the CO. Okay, adding that second and fourth, then you will get what you wanted, that you will get, means C plus half O2 will give you CO gas. Okay, then now this C, you will get the value of C plus half O2 CO gas you will get after adding these two, and for this automatically delta H also you have to add, delta H also you have to add, means minus 393 and plus 283, then you will get how much value you will get, then minus 110.5 kilojoule, because that value was 393.5 and now this was 283. Okay, then roughly 100 degree change, but exactly it will come 393 and 283 is there, 93, 83, then 10 degree, this 110.5 kilojoule minus 110.5 kilojoule, that heat will produce. Then see, you were not knowing, now you are knowing that C plus half O2, it will form carbon monoxide, then delta H, heat of reaction will be minus 110.5 kilojoule, means heat will evolve. In this process also heat will evolve, because carbon monoxide formation is there, then heat will evolve. Then like that way, this I told you one example, like that way there are maybe many examples, many numericals will be there, and same things you have to do, sometimes to bring the what you want, that equation you want to bring it, for that purpose sometimes you have to multiply, sometimes you have to multiply the whole equation, sometimes by 2, sometimes by 3, sometimes you have to divide also, but what you are doing all for complete equation, left side also, right side also. Okay, you have to divide both side, you have multiply both side, whatever you are doing equally you have to do. Okay, this how you have to do to get your you can say desired equation. To get the desired equation you have to do all the things, means common sense you have to apply, no fixed these things are there, correct, but only just by rearranging you can get the desired equation, and after that either you add or subtract as per your requirement, either add or subtract. Okay, and then you will get the desired product, desired equation plus delta H value will get accordingly. Don't forget that sign will change if you are reversing, never forget. Then like that way you can calculate the desired product. Okay, then here HESS law, here you are applying. How you will tell HESS law is applying? Then here you can see you have applied step by step, C plus half O2 CO one step, and CO plus half O2 CO2. Then either directly if you will burn C plus O2, complete burning initial to final, then it was 393, but step wise you are doing, means C plus half O2 CO, again CO plus half O2 CO2, then two steps are there. Then if both you will add, means C plus half O2 C plus half O2, that is a 283 plus 283 plus now CO plus half O2. CO plus half O2, CO2, that is 110, 110.5. Now add both value are in minus, you add, then you will get minus 393. That was the direct initial to final 393. But adding C plus half O2 and again C plus half O2 CO and CO plus half O2 CO2. Then in these two steps you add, then you will get the what you got directly. There here HESS law you are applying. Then just I have told you here meaning of HESS law by example. Okay. Then in general you can tell, in general, if enthalpy means always understand heat. Enthalpy means always there are two terms there, both have almost same meaning. Okay. Because it is just was recent and have little difference. I told you H is equal to E means internal energy plus work done. U, actually U is also, both term is used for internal energy, U and E, capital E, anyone you can tell. Then H is equal to E plus W. Okay, the W is work done and E is internal energy. Okay, if you will add both, then you will get H value, that is called heat content. H is equal to heat content. Okay. Then here in general, if enthalpy of an overall reaction A to B means A is the initial, B is the final, along one route is a delta RH means heat of reaction, and delta H, delta H1, delta H2, delta H3 representing enthalpies of reaction leading to the same product B along the another route, then add both, then delta H of the reaction will be delta H1 plus delta H2 plus delta H3 ... like that. Delta H will be delta H1 plus delta H2 plus delta H3 plus ... different route, A or B, directly you are getting one route and A to B another route in different steps. Just like sometimes bus will go direct without stopping, non-stoppage from one place to the other places. And ordinary bus, passenger bus, or train also you can tell that express train directly that after 4 hours it will stop or 6 hours it will stop. And sometimes passenger train every station there it will stop and they will reach there. Correct? Same type of concept is there. Then delta, finally you have reached to that place only where you wanted, but that was only in one stop. Train stopped only directly there, but passenger 10 places there, 10 stations they were stopped, then you reach to that place. Then same concept is there. I think you might have understood. Then delta H, heat of reaction, that is equal to, by one route, that is equal to delta H1 plus delta H2 plus delta H3 ... like this way. Okay. Then this you can represent this also like A to B, that is the, by diagram also you can represent A to B, that is the one route. Arrow sign you can put A to B, big arrow sign, long arrow sign you put A to B, and then that is the one route. Second route, A to B is the direct route. That is the delta H. Now second route, A to C and C to B and B to final route, finally your place you will reach, that is the B. Then A to C, again you put one long arrow, that is the H1, delta H1. Now you have reached to C, and then Now again you are going to the other station, C to D, that is the delta H2. Delta H2. Again from D you will reach to B, where you wanted actually. Then C to D, again a long arrow you can put. Okay. Then delta H2, again D to B, again a long D to B, again a long arrow you can put. Then delta H3. Then now you add delta H1 plus delta H2, delta H3. Then now you reach to the B, where you wanted. Means it will give a shape like just like a square. A square shape it will take. Okay. Or rectangle shape, no problem. Rectangle also, a square also. Then this just like it is become a diagram in examination. If question is asked, particularly for 11th I am talking about, then he has to mention. Okay. Then now I am stopping only here. Next class again I will discuss the enthalpy for different types of reactions. Okay. Then I think 4 types are there, common 4 types are there. Okay. Then I will discuss all 4 types. I will finish next class. Okay. Thank you.